So in this video I want to go over the lowest common denominator for rational expressions using factor trees, okay? Sometimes it's important to multiply two rational expressions together, and it becomes a lot easier, and the mathematics or the arithmetic becomes a lot easier if you use the lowest common denominator, not just any common denominator. Okay? So I want to use this example here first. X over 6. It doesn't matter what the numerators are, so I just put x and y. What we're interested in are these denominators, 8 and 6. So I could say, okay, common denominator, I can make these both, the common sense thing would be maybe to multiply 6 and 8. Okay, you get 48, and that's my new denominator. But there is a least common denominator, okay, for 6 and 8, and I want to show you how to find it. You might know it's 24, okay, but I want to show you how to get there by using these factor trees. Okay, so I have 6 and 8, and I want to break this up into their prime factorization, okay? So I want to break 6 up into all prime numbers, and that's easy. It's just a one step. Okay, 6 can get broken up into 3 times 2, and 3 times 2, they're both prime numbers. 8, not as easy. You have to break it up into 4 and 2, and then that 4 breaks up into a 2 and a 2. So the prime factorization of 8 is 2 times 2 times 2. Okay? Now to get the least common denominator, we just need to have all of the elements covered in both of these, okay? So the LCD is going to be, okay, well, I know I need a 3, okay? And I know I need a 2, okay? That covers my 6, okay? What about my 8? Well, I know I need 1, 2. Oh, I have 1, 2 here, so that's covered. I don't have to rewrite it. However, I don't have a second or a third 2, so I will have to write those in, okay? So we were able to eliminate one of these 2's because there was a 2 in both problems. So the LCD in this case is 3 times 2 is 6, 2 times 2 is 4, 6 times 4 is 24. So the LCD is not 48. We can actually use a lower number that might make the arithmetic easier, and that number is 24. All right, let's try that using rational functions. So we're going to break the rational functions, the denominators, into their prime factorization, and then we're going to see what pieces we need to put into our LCD. Okay, so I have these two rational expressions here. All right, so they're a little bit different. Instead of 6 and 8, I have these polynomials. But I'm going to break those polynomials up into their prime factors, just like we did with 6 and 8. And then we're going to pick the pieces that we want for the LCD. Now, yeah, sure, a common denominator would just be if I multiplied 5x squared plus 15x times x squared plus 6x plus 9. But that is some extremely ugly, it's going to be a quartic equation. And you don't really know how to use those too well. Nobody does. So we don't want to do that. We want to simplify our lives a little bit. So let's factor, I'll do it in red, this guy here. All right, well, if I factor that, I know I can take out what? I can take out definitely a 5, and I can take out an x, and then be left with x plus 3. Okay. Here, with this equation here, or this rational expression, we have a perfect square trinomial, actually. So this is x plus 3 times x plus 3. All right? These are our prime factorizations. All right? Just like how we had here, these prime factorizations, these two are our prime factorizations. So, for my LCD, first I'll go to this equation with the x on the top, and I'll say, okay, my LCD, I need a 5x, all right, and I need a x plus 3. Well, what else do I need? Let's go to our equation with the y on the top. I have one of the x plus 3's already listed, but I need to write another x plus 3. Okay? And this is going to be my common denominator. Okay? It's already fully factored. We don't have to worry that it's a cubic equation. And it's our lowest common denominator. I hope this helped a little bit in your addition and subtraction of rational expressions.